Hi class, in this module we're going to talk about the idea of functions. And let me go over a couple of definitions that lead us to the idea of a function. The first definition is a relation. Now, in mathematics, when we talk about a relation, we are talking about a set of ordered pairs. So in this case, a set of ordered pairs or coordinate points. So we're talking about a set such as 1, 2, 3, 7. So for this to be defined as a set of ordered pairs, we're going to have the squiggly brackets and then technically the coordinate points in here. We're assuming that the set is defined as x's and y's. So input, output, that's going to be the basic idea of a relation. Now, when we talk about the domain, we're referring to the x values. When we talk about the range, that would be the y values or the corresponding y values. And then also, when they talk about the x's, they're going to be referring as the input, y would be the output. As given here in the definition, these would be the x's, and technically the output would be your y values. Now, here's the basic definition of a function. We're looking at mathematical structures that for every x value that is selected, they're going to give you a unique y value. So that's what this definition is referring to. So any mathematical structure that every x gives you a unique y value. So you're looking at x's give you y's, and the same x cannot give you multiple y's. So that is basically stated here. So notice that this example is defined as a function. Every x would give you one y value, but this one is not, because this x is going to give you two y values. Same idea here, two y values. And then any equation that in the past we simply had it as y, if it's defined as a function, we replace y with f of x. So if before we had, the idea of y is equal to x plus 1, here we would basically say the function is equal to x plus 1, since this is just a linear function that will pass the vertical line test. If you're looking at y is equal to x squared minus 3, in this section, we're just going to call that this is f of x, which is equal to x squared minus 3. Same idea. We're just modifying the actual y for f of x. Or let me just give you another one. If we had y is equal to the square root of x plus 1, in this section, you're going to see this equation as square root of x plus 1. Since technically all of these will pass the vertical line test, or the idea that every x has a unique y value. The last topic that we're going to talk about here is if you were to flip your x's and your y's, and the idea of a horizontal line test. So the topic of the horizontal line test deals with inverses, but that's a topic that comes up later. And in this case, we're just referring to one-to-one functions, and what's equivalent to the horizontal line test, a function is going to be one-to-one. So we're talking about within the set of functions. If you draw a horizontal line and you don't have two intersections. So it's basically the same idea as a function, but if you switch the x and the y's. So at the moment, we're going to be testing for functions, meaning every x has a unique y value. And then we're going to be looking at within the set of functions if they have the property one-to-one. And one-to-one means that if you draw a horizontal line, it only has a unique y intersection. Now, let's take a look at the first example. And what they want us to do here is to determine if the relation is defined as a function. Now, the easiest idea to do here is the mapping. Remember that in this case, this is a relation which represents a set of x's and y's. Now, in the background, we are not given the actual, the actual equation that gave us these coordinate points. We're just given the coordinate points. So let me do the mapping. In this case, I'm just going to put the x's, which represent 1, 2, and 5. And I'm just going to say that this set represents your x's, and then your y values are going to be 2, 4, and 6. So these are our y values. And let me cover the mapping. So the mapping represents an equation that when you plugged in an x value, it gave us the y. And in this case, 1 goes to 2. So 1 goes to 2, it's there. 2 goes to 4, so 2 goes to 4. And 5 goes to 6. 5 goes to 6. Oh, there's a typo here. There's supposed to be another part of the parentheses. And what we're testing here is that every x value has a unique y value. So in this case, we would say yes, the relation is defined as a function since every x value has a unique y value as output. Remember what I mentioned, there is an equation that when you plug in the x's will give us the y's. In this case, the equation is not given, but x gives you y, x gives you y, x gives you y. And in this case, every x has a unique y value. Let's take a look at problem 2. Oh, problem 2, I see a problem. But let me first do the mapping. So you have your x's, and we have technically 2 and 4. So 2 and 4, we don't put repeats because it's going to be the same x. So in this case, 4, 2, and 4, and then your y's. So your y's, we have a 2, a 4, and a 6. Now observe this mapping. The first coordinate point gives us 4 to 2. So technically 4 to 2. Remember, x's go to y's. The second one gives you 2 to 4. So 2 to 4. So far, so good. But the next one is the one that causes the problem because 4 goes to 6. And here's the problem. The value of x is equal to 4 gives us two outputs. It gives us 2 and it gives us 6. So in this case, we would say no, the relation is not defined as a function. And then we would just say because, well, 4 comma 2 and 4 comma 6. And then let me just write that the x value of x is equal to 4 has two different y values. And what we're supposed to get here is unique y values. So that would be it. And once again, this one fails because of the x value of 4. It gives you a 2 and a 6. So technically not defined as a function. Let me go back to the definitions. You technically have this scenario here. An x giving you two different y's. We're supposed to get a single one. Let's take a look at problem 3. I think we have enough time within the video. And in problem 3, we're looking at the following. So our x's, let me put them as 8, 5, and 12. Our y's are going to be 2, 2, and 62. Okay, so 8 goes to 2. So wait, no repeats. So I need to erase this one. So 8 goes to 2, goes here. 5 goes to 2, goes here. And 12 goes to 62, goes here. Now, notice that this situation is okay. I do see that 2 x's go to the same y, but they're different x's. What you cannot have is 1x giving you 2 different y values. So in this case, we would say, yes, the relation is defined as a function since every x value has a unique y value. Now, let me explain the part of unique. So it's unique within the x's. So in this case, when you plug in 8, you're just going to get 2 and nothing else. So in this case, it happens to be unique. When you plug in 5, you're going to get 2 and nothing else. 12, you're going to get 62. What you cannot have is an x value giving you 2 different y values. So that's a scenario that we cannot have. In this case, this particular one is perfectly fine. We do have 2 x's that give you the same y, but the output is unique to the x's. That's actually it for these 3 problems.